Let's take a look at the following, the intersection and the union of two sets. Just a quick recap over here. If you look at set A, where all the elements are in red, set B, where all of the elements are blue, and then the two sets A and B are intersecting each other. They have a common region right here where they are meeting. Then the intersection of A and B would be, the common region that they do share, those elements that are common to both sets. The keyword for intersection is a keyword AND. Now, if you have the union, let's take a closer look at what's happening right here. And I have this on a separate paper, so let me go to that paper now. If you have the same two sets A and B, A is in red, B is in blue, and the two sets are overlapping each other. When I say A union B, I'm uniting the contents of A and B, and the union basically is related to the keyword or, the kind of inclusive or, not the IRS or where you for 1 year owe taxes or you get a refund. It's the other kind of or, which is called the inclusive or. And the way it goes is the following. When I say A union B or A or B, I mean that I'm okay with colors, no matter which ones they are, whether it's plain red, plain blue, or both colors. Notice we have three situations when I say A union B. I'm okay with the elements that are just red and not blue. Okay, check mark means you're okay with that color. X means you're not. So we're okay with just the red elements, which are basically in this portion of A. You're also okay with just the plain blue elements, this portion of B right here. So blue is okay, and here red is not okay. So that would be another option. And what is the third option that you do not want to forget? When you say A union B, A or B, with the inclusive or, you are also okay with having both colors, elements that are red and that are blue as well. So this middle portion over here, which really was the intersection, of the two sets, you are including that also when you're talking about the union. So it's this region that's all red, this one that has both colors, and this one that is blue, and that is part really, that are part of the union. So the union looks like that little shape over here. So let's look at this a little bit further. So when I say A union B, I'm interested in that shape that looks like what I call MasterCard or squished 8, and let's look at that a little bit more with the coloring that I filled in. So if you were to color all of this shape, you would get the gray feeling, which I have right here when you fill that in. So you have A union B is really, what you see right here, that shape, which I call MasterCard. It looks like the MasterCard logo, or what I call squished 8, if you want to call it something else. And that's what we have for A union B. Now let me mention a little something to you about the following. When you said that you had the inclusive or for the union, and you were okay with just red, just blue, or both colors, just think about it this way. Let's imagine that I were to give you 2 scoops of ice cream, and the flavors are strawberry, for red, and let's say blueberry for blue. And I told you you can have 2 scoops of ice cream, strawberry or blueberry, are the different flavors you have. If you use that mathematical or, the inclusive or, what it means is that you can have 3 different kinds of ice cream. You can have 1 cone that has, 2 scoops of just strawberry, or 1 cone that has 2 scoops of blueberry, or a cone that has both flavors, blueberry and strawberry at the same time. So number 1, this is what we had here. Only red, elements were considered here. Number 2, only blue elements were considered. And number 3, basically elements that show up in both regions, red and blue, were considered. So that's what you have in the third situation for our ice cream.